Hello, and welcome to my presentation. We are going over functions today. So, we're going to talk about linear equality, proportionality, and inverse proportionality. What is a function, function notation, the domain and range of functions, and more complex relationships, and the difference between functions and relationships. So first, we're going over linear equations. Now, linear equations are equations in the form of y equals mx. So y here is the dependent variable, with x being the independent variable. That means that y will change whenever x changes. Now, m is called the coefficient of x. It could also be called the scalar of x. It means that x is multiplied by m. And now c is a constant. That means it's not multiplied by x in any way. We are going over graphical interpretations of linear equations. So in our first graph, we have y equals x. And you can see there's no constant, and that means that the y-intercept is going to be 0. Whereas if you've got a constant of, let's say, 2, then the y-intercept is going to be 2. So you can see this is up a little bit further. Now, you could also have a horizontal translation, and that would be in the form of y equals m, x take b plus c, where b is a horizontal translation, and that is going to be a translation of b units to the right. So this is a vertical translation of 20 units up, and this here is a coefficient of x of a half. Now, this coefficient can also be known as the gradient, and we'll get into that later. And here we can see this translation. So these are both graphs of a half x plus 20, but this one here has been translated 20 units to the right. Okay, so now we're going to talk about slope, and slope is very important, and you're going to be studying a lot more in the future. Now, the slope of y equals mx plus c is actually m, and that's the gradient that I was talking about before. That's the coefficient of x. And in this case, that will be the slope. Now, the slope is known as the gradient, and it can be defined as y final, take y initial, and x final, take x initial. Now, it is also defined as the change in y over the change in x, and that can be using the delta sign or the d sign. And this is known as the derivative. And this is the basis of calculus, which you'll be getting into at the end of the year. Okay, so we're going to try and solve a problem here. So the problem states that we have these 2 points, 3-2 and 5-1. And we want to define a line that crosses both these points. And you only ever need 2 points to define a line. You'll need more points if it's a curve. You need 3 points for a quadratic, for example. We'll get into them later. So what we're going to do is we're going to use the derivative here, the change in y over the change in x, to define m. And you can just use y coordinate 2, take y coordinate 1, over x coordinate 2, take x coordinate 1. And as you can see, we've done that here. And you can do it with either one. It's both equations will work. So you've got 2 equations, one unknown, only needed one, so you can solve it either way. And as you see, we're going to solve, and we're going to get c is equal to 7/2, and m is equal to -1/2. And so that's going to give us the equation for this line here, y equals -1/2 x plus 7/2. It's quite intuitive once you start getting into it. Okay, and now we're going to go into perpendicular lines and solving problems with perpendicular lines. So in this case, we have a line y equals mx plus c, and it is perpendicular at point k equals x1, y2, and it has a slope of m perpendicular. Now we're calling this m perpendicular because it is perpendicular to the line y equals mx plus c. So this is arbitrary. I didn't have to call it m perpendicular, but I think that's a good name so you know what we're talking about. And the key to solving these problems is knowing that m perpendicular has a gradient of -1 over m, where m is the regular m from the equation y equals mx plus c. And the equation of this perpendicular line is then going to be y equals -1 over mx plus b, where b is a different constant to the initial constant. So to solve these types of problems, you're going to need either the equation of one of the lines and the point k, or a point on each of the lines and the point k. So if we look at this question here, we have a point on this line and the equation for one of the lines. So that is the two things we need. All right. So we got y2 equals m perpendicular x plus b. And so that's going to equal -1 over m. And we can see here that m is -2 because y equals -2x. So then the gradient of y2 will be 1 over 2. So it's the inverse of this gradient. That is the easiest way to do it. It is the negative inverse of this gradient. Now, y2 equals half x plus b is our solution. But what is b? Well, we're going to use this 4 here. And what we can see is that 4 is going to be equal to half x take 2 plus b. So it equals -1 plus b. So b equals 5. And there we have the equation. Just simple rearrangement. Should be easy for you guys. You got this. Trust me, you got this. Okay. So now what we're going to deal with is parallel lines. So parallel lines do not intersect. They have the same gradient because they're never going to intersect. And if they had different slopes, see, they're going parallel forever. They'll never intersect. But if they have different slopes, eventually they're going to intersect, even if it's just a little bit, because they're going on forever. One day, they're going to intersect. All right. The lines are either, if the gradients m1 equals m2, then the lines are either parallel or coincident. Now, coincident means that they are literally the same line. So what this is saying is that they will either never meet or they have to be the same line. That is the only two ways that they can be parallel. Now, a parallel line will either be a vertical or horizontal translation of the line that it is parallel to. So if you imagine here 2 lines, well, this is just one line, and then you're going to translate it vertically, or you can translate it horizontally. And there you go. The skills of advanced mathematics is thinking for yourself. So I suggest that you think of the following equation. y2 is parallel to 5x plus 2. What is the equation of y2 if 0-88 is a point on y2? Now, in the perpendicular section, you have been given all the tools to solve this problem. All you need to use is this new definition where instead of m1 being the negative inverse of m2, it is m2. They're exactly the same gradient. You've got this. Okay, I'm going to talk to you guys about this thing called proportionality. And I'm going to also talk about inverse proportionality. So proportionality, I think I'm going to do this by an example. So I want you to consider a scenario where you get $5 for every 3 apples that you sell. This relation could be defined by the equation profit. So that's the money for every 5 over 3 apples. And this is proportional. This is a proportional relationship where an increase in the apples is going to lead to an increase in profit. They're both. An increase in one means an increase in the other one. And a decrease in apples will cause a decrease in profit. If you sell less apples, you will not make as much money. That is guaranteed. And so you can denote this proportional relationship. Profit is proportional to apples. And they've used the alpha sign here. So this is the Greek sign alpha. And I think it looks pretty good and does a very good job of showing that they are proportional. I think it shows a good association. I like it. I think it's a good symbol. And you can also have negative proportionality. This is not inverse proportionality. This is a different thing. But what negative proportionality means is that an increase in sales means a proportional decrease. So increase, decrease. So this would be like if you were being paid not to sell apples. So if you sell an extra apple, you will be paid less. That is negative proportionality. Okay, we have talked about proportionality, but what about inverse proportionality? What is that? Well, I want to go back to the Apple store. Let's go back to this Apple store. You are selling apples. You know how much money you're making. You sell 3 apples, you make $5. You have got that sorted out. But it actually matters how long you take to sell these apples, right? If you sell 3 apples in the first minute you open, 3 apples, $5. That is a good profit. That is $5 a minute. You will be a billionaire in no time. It is just a matter of time. But what if it takes you 8 days to sell 3 apples? I'm sorry, you're not going to be a billionaire. That is just hard, cold facts. All right. And so inverse proportionality is the relationship between profit and time. So the more time it takes, the less profit you're going to make hourly. So your hourly profit will decrease as time increases. So obviously you want there to be less time so that you get more profit per hour. You could also make more profit. So if you sold 100 apples over 8 days instead of 3, you'd be doing a little bit of a better job. Maybe you're not so bad at selling apples after all. Maybe there's hope. And so we do know that as you can see here, profit over 7 hours is going to be less than profit over 5 hours. So an increase in hours leads to a decrease in profit. Good. All right. And you can see it is different. It's because it's not quite, you're not getting paid to not sell apples. You're getting paid less for taking longer. So that's the distinction between negative proportionality and inverse proportionality. And it's okay. An inverse proportionality is again denoted with the alpha symbol, but this time you can see that it is the alpha symbol and then 1 over t. So instead of it being proportional to t, it's proportional to 1 over t. It is inversely proportional to 1 over t. 1 over t is the inverse of t, therefore it is inversely proportional to t. Okay guys, we're going to talk about asymptotes. Now this graph here that we're looking at is similar to the inverse proportionality we're talking about. It's a little bit different because it's got this constant plus c and 20 over 10. It's got some constants, but it's got this same relationship where the independent variable is on the denominator, not on the numerator. And that's when we get graphs like this. Whenever you have the independent variable on the denominator, you are going to get a graph that looks like this. And these graphs have these things called asymptotes. And what is an asymptote? Well, I want you to look at this red line. Now, the blue lines are never going to approach that red line. They're never going to get there. They're just going to get, here's the red line. They're just going to get closer and closer and closer. But no matter how far they go, they'll never touch. They'll just keep, because as they get closer and closer, this number here is going to get smaller and smaller and smaller. And so what you're going to find is that y is just going towards 6. It wants to get to 6. One day, when this here is equal to 0, y would equal 6. But the thing is, this term here will never equal 0. It never will. So y will never reach 6. Okay, so what about this other asymptote, the vertical asymptote? We've already gone over the horizontal asymptote because this term cannot equal 0, then y would never equal 6, hence the horizontal asymptote. But what about the vertical one? Well, here's the thing. The denominator can never be 0. It's not going to happen because you cannot divide by 0. It is impossible. You have to remember that division is the opposite of multiplication, but yet there is nothing in the world that you can multiply by 0 and get 20, which means that you cannot divide 20 by 0 and get an answer. So there is going to be this vertical asymptote when 4x plus 10 equals 0. And that is going to be, when 4x plus 10 equals 0, that vertical asymptote is going to be at x equals negative 2.5. Now, do the algebra. You got it. We're going to go over inversely proportional graphs and graphs where the independent variable is on the denominator. So this first graph is inversely proportional. As x increases, y will decrease. It is clear. And you can also have y equals a over x. You can have y equals ab over x. These are inversely proportional relationships. As these other relationships have constant terms, so they're not inversely proportional, but they still apply to these these are translations of inversely proportional graphs. They follow a lot of the same rules. They all have asymptotes. So let's say you want to translate a over mx to the left. Well, you are going to use a equals mx take b, because what this is going to do is translate it b units to the left. If it was plus b, it'd be b units to the right. Now, this graph here, what's the problem with it? Let's talk about this graph, y equals a over mx plus c. How many units is that going to the right? It's correct, but it's harder to read. And you often see graphs written like this because a lot of times that's how they're written. If you wanted to know how much this was translated to the right, you would need to take a factor of m out. So you can tell that this graph would be translated to the right, c over m units. Now let's talk about the far to the right graph. This is going to be y equals a over mx take b plus d. The positive d is actually a translation up. You can see that it is exactly the same as the graph to the left of it, but it has been translated up d units. All right, guys. So now this is the most important part of the whole video. This is an idea that you're going to take with you for the rest of your mathematical lives. If you study engineering, mathematics, functions are something you will deal with all the time. They underpin pretty much all mathematics that you're going to do going forward. So, what is a function? A function is a set relationship between a set of values, between sets of values where every value in one set is related to only one value in the second set. Hence, for every one x value, this maps directly to a y value. It doesn't map to two y values. It only maps to one y value, all right? A y value can map to two x values, but an x value can only map to one y value. So I want you to consider the function y equals x, where y is the dependent variable and x is the independent variable. This function can be written as the function of f of x equals x. And so now you've just learned function notation. All right. Okay. So the domain and range of a function. The domain is the set of values for which the function is defined, and the range of the function is the values that that function takes. Now, how do we look at this? Well, the easiest way to look at this is that the domain is the x variable. It is the independent variable. It is all the values that the independent variable could be. And the range is all the values that the dependent variable could be. Range is y, domain is x. So consider this function right here. The function y equals 1 over x has the domain x cannot equal 0, and the range y is in the set of all real values. So all real values, what does that mean? Well, it means the values are not imaginary. You'll learn about that later, but basically all the numbers that you know about today are real numbers. You'll learn about imaginary numbers later, and they're pretty cool. Now, I've got some notations here. So you see this notation with the round brackets. We've got negative infinity. So we've got round bracket, negative infinity, comma, infinity. And then we've got the union sign, and then we've got infinity, 0, comma, infinity. So these round brackets mean that it is not inclusive. So it is saying that negative infinity is not included in the set, and it is stating that 0 is not included in the set, but everything in between 0 and infinity is included in the set. Now you've also got y is in the set of negative infinity to infinity. So negative infinity and infinity are not in the set. There is no negative infinity, but every number up to negative infinity is in the set. There's also the inequality notation, and that's these arrows here. And also I would like to mention the inequality notation, which is using these here. So the inequality notation uses the arrows So this is saying less than or equal to, and this here is less than. But the set builder notation uses these curly brackets as well. Really, it's just if you're trying to define a set, which you're not really going to be doing until much later in your studies, you want to use these values. But if you're just talking about the range or domain of a function, you're probably going to be using inequality or interval notation. And so square brackets in interval notation mean inclusive. So in this case, it is 0 to 1, where 0 is included and 1 is not included. And for instance, this graph here is 0 to 1 included. 0 and 1 are included. They are not excluded. Now, let's do it. Let's go over functions versus relation. What is a function and what is a relation? Remember how I said that if every y value maps to exactly one x value. So remember how I said if every x value maps to exactly one y value and no more y values, it is a function. Well, let's have a look at this one here. We've got x equals -4. Well, look at that. That can only ever be this one y value here. It looks like it's about 18. Now, 18 can be two y values, but -4 can only be one x value. So get that? One x value for every one y value for every x value. But a relation is different. There are two y values for every x value. So here we have -8, and you can see that y could either be this value or the value below it. It could be two values. And so the best way to test it is the vertical line test. If you can draw a vertical line going through your function and it only cuts the function once, then that function is a function. If it cuts the graph twice, it's actually a relation. It is not a function. I will just mention here this notation. You see this little arrow? It's pointing both ways, or you can write IFF. And what this means is if and only if. So this statement on the left will only be true if the statement on the right is true. That is going to be used a lot in your life. So it's good to like pick these things up straight away, get into the mathematical notation. Not a function, a function. I think you got this. Okay, let's go over some more complex relationships. What about a circle? How do you define a circle? Well, is a circle a function? No, it's a relationship. You try and draw a straight line through it, it's going to hit it twice. It will not hit it once. But if you rearrange the equation of a circle, so we've got the equation of the general standard form and the general form of a circle. Well, let's rearrange the standard form so that we've got it with y on the left-hand side. So let's rearrange this equation to get y on the left-hand side. And when you look at that, you've got y equals plus or minus the square root of r squared, take x, take a squared plus b. Well, you can divide this because plus or minus just means it can either be plus or it can be minus. So you could divide this relation into two functions. Y equals r squared, take x, take a squared plus b, or y equals negative r squared, take x, take a squared plus b. So you can divide this relation into two functions. You can get a relation, which is not a function because it can't pass a vertical line test. And you can separate it into two semicircles. And then each of those semicircles is a function because they will pass the vertical line test. Here's the equation for an ellipse. That is another relation. It's a complex relation. You're going to be using these formulas. I'd write them down in your notes. I'd pause the video and write these down. And so how does an ellipse work? Well, if we've got our circle, we've got x take a. So x is, if it was x squared plus y squared equals r squared, it'd be in the center. And the radius would be r squared, would be r. R would be the radius. But when you've got the take a, that is going to move it to the right. And the take a is going to move it a units to the left. And the take b is going to take it 2 units down. It's going to take a b units down. If you look at the ellipse, you're dividing these. So you're doing x take a squared divided by k. So you're actually squeezing it. You're squeezing the x. Or you can be squeezing the y. That's what dividing by L is, it's squeezing it. That's how you're getting this ellipse. You're not getting a circle. And we really do have to observe this very interesting complex relationship, y squared equals x. So you're going to do y equals x squared, and that's a function. But this y squared equals x is a relation. It's going to be a graph that looks like this, and it will fail the vertical line test. And this is another, I'm going to keep showing you this notation plus or minus because you'll see it all the time. So here, y equals plus or minus the square root of x. That's if you solve for y squared equals x, that's what the solution is. Well, that means you're going to get that for one x coordinate right here, you're going to get two different y coordinates. You're going to get plus root x and minus root x. And so it's a relation. And now let's have a look. So the square root symbol, yeah, let's have a look at this though. This is a very interesting function. So y equals plus or minus the square root of x. Let's just take a note that when you take the square root of something, this is always the positive case. That's why if you have x squared and then you square root it, you're going to get x, but you need to write plus or minus x because the square root only considers the positive case. But if you have negative x and negative x multiplied by each other, they will make x squared. So you need to also consider the negative case. And it's a useful note. Just think about that. All right, guys. That is the end of my first lecture. I hope you have enjoyed watching. Now, yeah, please rewatch the video, watch any parts you didn't understand, and make sure you have detailed notes. I'm not going to talk about everything I write in the slides, okay? I'm just going to sit here talking. I'm going to try and cover everything, but you probably want to write down the things that are in the slides because usually they're important. I don't put them there for no reason. So the next topic that I'm going to do is quadratics, and then I'm going to move on to trigonometry, then exponentials. We are going to go quickly through the functions. This is not going to be a slow course. And then next, after functions, then we've got statistics. We're going to keep moving. I'm going to get you all the way to calculus in no time. Now, if I am going too slow for you, because if you are watching this, you are probably the kind of person who wants to supplement their learning and get ahead. And if you want to watch, if I'm too slow, please speed it up to 2 times speed. Watch me speaking twice as fast if that is what's good for you. When you go to uni, you will do that. Every engineering student in my degree uses 2 times speed that I know. I haven't met somebody who says they don't watch lectures at 2 times speed. That's just what you do. All right. Thanks, guys.